the swings, the slams, even the saves. In the National Hockey League, things collide, but nothing on the ice takes as many hits as the puck. Weighing in at 6 ounces, this 1-inch by 3-inch black cylinder is made of vulcanized rubber. It's often kept in the freezer before games to minimize its elasticity.
When the pucks bounce around, we call that grenades. It just kind of bouncing everywhere. You don't know where it's going to go, and it blows up and hits your stick.
During a game, every movement of the puck follows the laws of physics and illustrates the concepts of force, impulse, and collision. Force is the push or pull that can accelerate an object by changing its velocity or by changing its shape.
In order for something to change its state of motion, there has to be an unbalanced force.
Jim Gates is a theoretical physicist at the University of Maryland and has been supported by the National Science Foundation.
Suppose that as the hockey puck is sitting there, I suddenly come along and hit it with my hockey stick. I exert a force in this direction. There's nothing pressing back in that direction. That unbalanced force causes the acceleration.
The force of an object is equal to its mass multiplied by its acceleration, commonly expressed as F equals ma. But scientists often write it as A equals F divided by m, which makes it more obvious that the greater the force applied to an object, like a puck, the faster it accelerates.
When you come with a stick and you wrap that hockey puck really hard, you're applying a big amount of force to it, and so it accelerates off really fast. On the other hand, you just give it a gentle tap that just leisurely slides across the ice.
The passing and shooting of a puck are also examples of an impulse, which is the measure of a force applied for a time.
The impulse is an important concept in hockey because most of the time you are applying forces for only a very short time.
Robert Gertz is an astrophysicist at the University of Minnesota and has been supported by the National Science Foundation.
For example, when you shoot a puck by swinging your stick at it, the force you apply to the puck acts for just a split second, then the puck is gone. That's an impulse.
To calculate an impulse, the applied force is multiplied by the amount of time it's applied, represented by delta T. On a graph indicating force versus time, a larger force or a longer time for the force to act creates a bigger impulse. The bigger the impulse, the bigger the change in the speed of the puck. Conversely, a smaller force or shorter time creates a smaller impulse.
So when you're dribbling the puck, you're applying little impulses to move the puck back and forth, but you don't want to apply a big impulse because the puck will get away from you.
Once the puck starts, it will continue to move until another force acts on it, like a collision with the boards or a goalie's glove.
All the goalie coaches, they're trying to teach us stop the puck at first, But the best thing is to catch the puck with no rebound.
A collision is when one object touches another object. It's called an elastic collision if the object bounces off and retains its energy of motion.
Well, the boards are pretty hard and they're pretty massive, and so when the puck hits the boards, it basically bounces back with the same speed that it was coming in at.
During an inelastic collision, some of the object's energy is transformed into heat through friction or deformation, or into some other type of energy.
An inelastic collision would be exemplified by a puck hitting a player. The player has soft padding on, and so the puck just sort of dies when it hits. This is what a goalie wants, a totally inelastic collision so the puck drops on the ice in front of him and he can smother it.
You're going to trap a lot of pucks against your chest protector. You're going to use your pads that you wear on your legs. Even sometimes you use your skates. So it's anything you can get in front, you're going to use, even your head.
Whether the forces and impulses are working with it or against it, for the puck, a hockey game is one collision after another, all the way to the net.